0.84 millimeters. It's about the thickness of a credit card, but in WayKen, it represents the minimum wall thickness of a medical device housing. When dimensions are pushed to the limit, precision and stability are tested at the same time. Plus or minus 0.025 millimeters, with extremely high demand on process consistency. Aluminum 6061, which is highly sensitive to changes in cutting forces. So when wall thickness is compressed to its limit, how can WayKen consistently produce 400 parts and ensure every single wall thickness falls safely within spec?
This is what we are going to talk about, a real-world machine case we completed recently.
Before entering mass production, we started with one critical step, first article inspection. Not as a formality, but as a way to fully identify potential process risks. During first article measurement, we detected a subtle wall thickness variation across different thin wall locations. At positions designed with equal nominal thickness, actual measurements range from 0.823 mm to 0.861 mm, with a total variation of 0.038 mm. These results told us clearly, under the currently processed condition, thin wall accuracy still had room to optimization. We traced the issue back to the early process design. In the small batch stage, we had chosen a high-efficiency, stable fixturing solution, combined with a larger diameter cutting tool. From a cycle time and cost control perspective, this was a proven and a reasonable approach. However, once machining entered the thin wall finishing stage, the process behavior began to reveal itself.
As the material removal process leads, clamping forces from both sides of the fixture acted directly on the thin wall area, causing localized micro deformation.
At the same time, the cutting resistance and the rigidity of the larger tool amplified the machining stress at the thin wall section, compromising wall thickness stability. The solution wasn't to start over, but to precisely adjust the key variables. First, we redesigned the fixturing approach. The original front and rear clamping was replaced with a top-down pressure plate system. By changing the force direction, we effectively reduced deformation during final machining. Second, we optimized the machining strategy. The finishing tool was changed from 5.6 mm to 5.4 mm, reducing cutting forces and making thin wall finishing more controllable and stable. After optimization, we remeasured the thin wall areas. The results were clear. Wall thickness at all measured points stabilized around 0.84 mm, with a maximum deviation of within 0.002 mm. Accuracy was stabilized. All results fully met the drawing requirements. For small batch, thin wall, high-precision components, WayKen has developed a mature, repeatable process logic for quality and consistency control.
What gets delivered is not just a part, but a result that has been validated to remain reliable in mass production.